and welcome. I get quite often the question about my soldering equipment, and today I would like to talk about it. As I was a student many years ago, I had an old and clunky soldering iron similar to this one, which I got from my neighbor as he wanted to throw it away. I am a software engineer and didn't solder a lot back then, but as my interest in the electronics started to grow, my friends gifted a 30-watt soldering station to my birthday. After a while I needed some extra tools, so I found this set with pliers, solder pump and other tools which names I don't know, but found useful. In the set there was also this 60-watt soldering iron. Most of the time I continued to use my 30-watt soldering station, which worked fine, but I had a very small table and the station took too much space, so I started to use this soldering iron instead more and more often. This soldering iron you can also see quite often in my earlier videos on this channel. Despite that it was a dirt cheap supplement to some tools that I needed, I actually used it for a very long time, to be honest. With some practice, it turned out that it doesn't play such a huge role which soldering iron to use, as long as it holds the temperature reliably. And this one did. I even was able to do more precise work using it, like soldering TMUs on a 3DFX Voodoo cards or reflowing solder on various ICs. The soldering iron did the job. It supports variable temperature, which can be set with a wheel. And it came with different tips, which can be replaced by unscrewing the front part. And here we come to the weakness of the soldering iron and why I use another one today. Here the heater element is hidden inside and the soldering tip is heated from inside. First of all, this is inefficient. Second, the tip of the soldering iron reacts slowly to temperature changes. And third, the most annoying part is it takes up to 10 minutes to heat up to around 300 degrees Celsius. This is very distracting if you want to solder something fast and continue with whatever you did. Sitting there and waiting 10 minutes until the soldering iron gets hot was a pain. Luckily, meanwhile, new compact and highly efficient soldering irons became more and more popular. Before that, you needed an expensive soldering station to have a reliable and fast soldering iron, but with those new digital soldering irons you could suddenly get something handy for a price of a lunch. The benefit of those irons is that they have a microcontroller which controls the temperature. Most of them have a screen and many useful features like automatic standby when the soldering iron is left untouched for some minutes. But even more important is that they use integrated tips where the heater is placed directly in the tip. Such tips are much more efficient, more reliable in regards of temperature stability and heating up in only a couple of seconds instead of minutes. Before such cheap soldering irons hit the market, integrated tips could be found exclusively on expensive soldering stations. Now it became affordable to everyone. So I got this SH72 soldering iron as a gift from my wife with a set of tips a couple of years ago, and I still use it from time to time. It's nothing fancy, but it works like charm. The temperature can be set with a wheel, the tips are very easy to switch, and the tip gets to 300 degrees Celsius in about 10 seconds. Before I used a 90 volts notebook power supply to power this soldering iron. Today I use it through such a USB-C adapter with a normal 65 watts USB-C power supply, which I also use with another soldering irons. This video is not a commercial for anything, it's just my honest opinion, but meanwhile I also use this FNIRSY soldering iron a lot, and recently I got the next version of it from my friends as a birthday gift. It comes with a set of tips, but it is still yet to be tested, so I can't tell a lot about it now. So back to the question, which soldering iron I would suggest? Well, I used and use different soldering irons. Eventually it's not about which one to take, but as so often it's all about experience. Once you get used to it, you can even work with the cheapest one from your favorite online shop. I'd suggest to take something with more than 30 watts so it can maintain stable temperature on the tip and something what heats up fast. This is what turned out to be important for me. Everything else is experience. None of those soldering irons will magically make you a soldering expert. I used tons of scrap for practicing soldering and desoldering parts over and over again. Today I use whatever I have at hand, even this gas soldering iron, which is kind of cool too. Without the tip, it reminds me a bit on a lightsaber. It is very useful if I have to solder something or cut plastic far from a wall plug. Of course, I use it quite seldom though. Soldering tips are kind of important, but once again they are also experience dependent. For bigger soldering joints, I of course use bigger tips. For smaller joints, well, obviously smaller. A very common mistake here is that many beginners think that a thinner tip is easier to use with smaller parts. But it's not necessarily the case. The problem is that the heat is transferred over the surface, and very thin tip has obviously a little surface, which is often not sufficient to heat up the joint or the pin of a chip which you want to solder. That's why smaller tips often need more experience and also good quality solder. My most commonly used tip is such a cut-off cone with a small surface. I think this is the easiest one to start with. But all in all, as I said, tips are a matter of experience and own preference. This was about soldering, but what about desoldering? This is something what I would consider even more important than the soldering itself, because desoldering brings much more potential to damage the PCB. For the through-hole parts, I use either this hand pump, if there are only few solder joints, or come up with the automatic desoldering station ZD915. Hand pump can be hard to use, especially if you have very old solder joints or multi-layer PCBs with bigger copper planes. It usually takes a lot more time to desolder something with a hand pump than with an automatic desoldering station. I will not go into details because I already made a couple of videos about this tool and you can find the links in the description. I use this tool very often if it is about desoldering through whole parts, like Dallas RTC modules or any other chips. For the work with SMD parts, I use this cheap hot air gun, which can be set to temperatures between 150 and 450 degrees Celsius, as well as 3 levels of fan speed. Not great, not terrible, but it works. If you repair older electronics from time to time, a desoldering station is a must-have. Which one you take depends basically on your budget. They start at around €100, but again, doesn't matter which one you choose, you will have to practice a bit. As a tip, very often I combine these two tools, preheating the PCB with the heat gun and desoldering the parts with the pump. It turned out to be the most gentle way to remove the parts from the old PCBs, especially if they have bigger copper planes, which dissipate a lot of heat. Without preheating, the risk of ripping off the pads is much higher. Of course, the preheating should not go too much over 100 degrees Celsius to avoid any PCB damage. That's about the soldering and desoldering tools. Now, what else is important? Of course, the solder and the flux. Here I have various options. As a flux, I usually use this kind of Stanol soldering fat, which I got in my local electronics store here in Germany. I also have this gel, but I don't use it too often, to be honest. Solder is meanwhile kind of a problem. It's getting hard to find leaded solder, which is a lot easier to use because its melting point is lower. Most of the solder which you can buy today is lead-free. It is okay, but you need 100 degrees Celsius higher temperature to solder with it, what can damage old PCBs, which are not made for such temperatures. I had some leaded solder in my basement, but some time ago I ran out of it and had to search for a supply. Recently I bought some samples to try and also got some old solder as a donation from a viewer. but I didn't try all of them yet, and I'm not ready to make a conclusion in this video. Maybe I'll do a separate video about it. Please write in the comments if you are interested. In regards of solder, I would like to mention something else. Here I have a can of so-called rose metal. It's a special alloy which contains 50% bismuth and about 30% lead. This alloy has a much lower melting point at around 100 degrees Celsius. Just for comparison, normal leaded solder starts to melt at around 200 degrees Celsius and lead-free solder from around 300 degrees. When desoldering old parts, you often want to avoid overheating, especially on SMD parts like CPUs. And rose's metal can help with that. It can be added to the solder joints functionally, where it gets mixed with the old and maybe even oxidized solder, bringing the melting point down. So if you use a heat gun later, you don't need to heat up the chip to a higher temperatures than, let's say, 150 degrees Celsius. It's quite helpful, but also not very healthy, so you should use a mask or a good ventilation, which is a good idea anyway. Well, what else did I want to mention today? For SMD soldering, I use this kind of solder paste and my terrible heat plate, which is very sketchy, but does what I need it for. I showed it in the past how I soldered my Socket 7 VRM project using this, and it did the job. I still love to see how SMD parts are magically pulled straight by the surface tension of the melting solder. As I previously also mentioned, different small tools can help as well. I have different tweezers, like these stainless steel ones, or made of ceramic if you need something non-conductive. I also use these high precision tweezers made of titanium, I think. They help a lot with straightening of the tiny SMD pins as well as placing SMD parts. Much better than my clunky stainless steel tweezers. There are so many other things to say, like heat-resistant Kapton tape, which helps to protect the parts around the soldering spot, wires, holders, lenses, microscope. Okay, that one I already covered in a dedicated video as well, but there are definitely other things which I forgot to mention. And that was only about soldering, not mentioning the other stuff. So if you are interested in such kind of topics, please let me know in the comments what else you would like to hear about. Or maybe you use some great tool which you think everybody needs in such an electronics repair workshop. Please share your experience in the comments. And so far, this is it for today. Thank you for watching and goodbye.